Assalamualaikum and a very good morning to our lecturer Dr. Fuad and all my fellow friends. My name is Sarah binti Nizar and I'm from Group 1. So today we would like to present to you about our method of characterization, which is mass spectrometry. So what is a mass spectrometry? Mass spectrometry is an analytical tool used for measuring the mass to charge ratio M over Z of one or more molecules present in a sample. The measurement of M over Z can be used to calculate the exact molecular weight of the sample. What are the functions of mass spectrometry? So, mass spectrometry is to identify the unknown compound via molecular weight determination. Second, to quantify the known compound. And lastly, to determine the structure and chemical properties of the molecule. So there are three basic components in mass spectrometer. First is ionization source. So what happens in ionization source is molecules are converted to gas phase ions so that it can be moved about and manipulated by the external electric and magnetic field. Second component is mass analyzer. Once the molecule is ionized, the ions are sorted and separated according to mass to charge M over Z ratio. The mass analyzer often works together with the ion detection system. And the last component in the mass spectrometer is ion detection system. The separated ions are measured and sent to data system where the M over Z ratio are stored together with their relative abundance. So here is the spectrum of mass spectrometer. So a mass spectrum is simply the M over Z ratio of ion present in sample plotted against their intensity. So each peak shows a component of unique M over Z in the sample, and the height of the peaks indicates the relative abundance of various components in the sample.
Hi and Assalamualaikum to everyone. My name is Fatin Azmira Huda binti Maontong. Now, I'm going to tell you about working of mass spectrometry. Before that, we need to remember that this mass spectrometry was used to figure out the various isotopes of an element and what is their relative abundance. Okay, so firstly, we need to inject sample in this instrument and then we need to heat the sample up to vaporize it. So when the molecule sample will be bombarded with a beam of energetic electron. So it will ionize the sample. From ionizing, the sample will have electron charge, whether it's positive or negative. So the particle charge will accelerate into this boost silver plate and then rapidly goes into this magnetic field. Uh, this magnetic field was used to separate particles based on mass over charge ratio. So it will bend the charge ratio if it has um, larger mass, so it will bend less. But if it has a smaller mass, so it will bend more. So the detector will detect this isotope and form a charge like this. For x-axis, it is a mass to charge ratio, while the y-axis is the relative abundance. So this 1, 2, 3, 4, 5 is the isotope that exists in the element. So basically, from my presentation that I tell you about in this technique, molecules are bombarded with a beam of energetic electrons. The molecules are ionized and then broken up into many fragments, some of which are positive ions. Each kind of ion has particular ratio mass to charge. From most ions, the charge is 1 and mass over ratio is simply the molecular mass of the ion. So the ion pass through magnetic and electric field to reach detector where they are detected and signals are recorded to give a mass spectra. So from this, you can know that This is the highest relative abundance, which show that it is the most isotopes exist in our nature. Okay, that's all from me. So I will continue to Ida.
Instrumentation and step of mass spectrometry. The diagram shows the basic principle of mass spectrometry, then indicates inlet, source, analyzer, ion detector, and data system. There are several steps of mass spectrometry, and first step is sample inlet, which is known as sample introduction. Sample stored in large receiver from which molecule reach ionization chamber at low pressure in steady stream by a pinhole called molecular lead. And next step is ionization. Atoms are ionized by knocking one or more electrons to give off positive ion by bombardment with a stream of electrons. Most of the positive ion formed will carry charge of positive ion. Ionization can be achieved by three techniques, which is electron ionization, chemical ionization, and desorption technique. Next step is acceleration. Ions are accelerated. So ions are accelerated into a finely focused beam. They all have same kinetic energy. And positive ion passing through three slits with voltage in decreasing order. So in this diagram, it shows a three slits with a voltage with last plate with a voltage of 0. And the middle plate is the intermediate plate. Next step is deflection. Ions are deflected by magnetic field due to due to difference in their masses. Amount of deflected depends on two factors, which is the mass of ion and the charge of the ion. For the mass of the ion, the lighter the mass, more they are deflected. And for the charge of the ion, the more positive charge an ion is carried, more it will deflected. So these two factors are combined into a mass over charge ratio. In the diagram, we can see the ion stream A is most deflected. So it means it will contain ion with a smallest mass over charge ratio. For the ion stream C, it shows the least deflected. So it will contain ion with a greatest mass over charge ratio. And for the last step is detection. The beam of ion passing through the mass analyzer is detected by detector on the basis of mass over charge ratio. We can see in the diagram, when the ion hit the metal box, the electron jumping from metal into the ion. So the charge of the ion will be neutralized. The flow of electron in the wire is detected as current, which can be amplified and recorded. The more ion arriving, the greater the current detected. So there are several types of analyzer, which is magnetic sector mass analyzer, double focusing analyzer, quadruple mass analyzer, time of flight analyzer, ion trap analyzer, and ion cyclotron analyzer. That's all from me, and we continue with the example from Yakin.
Here are some examples on how to interpret the mass spectrum. This is the first example, which is the mass spectrum of acetone. So, as you can see, on the horizontal axis is the value for the mass to charge ratio, and on the vertical axis is the relative abundance of each ion detected. On this scale, the most abundant ion is called the base peak. So all the other peaks are recorded relative to this value. For acetone, the base peak corresponds to a fragment with the ratio equals to 43. So as we know that the molecular weight of acetone is 58. So on the ratio of 58, the peak is known as molecular ion peak. So there is a M+1 peak, which is a greater mass than the molecular ion peak. And this is because about 1.1% of all the carbon atoms in the nature are actually the carbon-13 isotope rather than carbon-12. The carbon-13 isotope is heavier than carbon-12 by 1 mass unit. Therefore, there will be a peak of 59 after the molecular ion peak of 58. So in addition, uh, about 0.015% of all hydrogen atoms are actually deuterium. So the M+1 peak represents those few acetone molecules in the sample which contain either a carbon-13 or hydrogen-2 isotopes. This is the second example. This is the mass spectrum of pentane. Pentane has a molecular weight of 72. Therefore, the mass to charge ratio at 72 is the molecular ion peak, and the base peak is at the peak of 43. The base peak is the tallest peak because it represents the commonest fragment ion to be formed, either because that there are several ways in which it could be produced during fragmentation of the parent ion, or because that it is a particularly stable ion. At the mass to charge ratio of 57, so fragmentation occurs. So to get this 57, the pentane ion produce a cation which consists of 4 carbon atoms and 1 methyl radical, and the methyl radical produced will be get lost in the machine. For the charge for the mass to charge ratio at 43, it could be calculated in the same way. So the pentane cation produce a 3 carbon ion with a molecular weight of 43, while for 29, ethyl ion is produced. So for the other lines in the mass spectrum, they are difficult to be explained. For example, the lines with the mass to charge values 1 or 2 less than the easiest line are often due to the loss of one or more hydrogen atoms during the fragmentation process.